Hi, welcome to Windows Server 2016 What is New course, Part 4 for today. With Part 4 we have A and B. We will cover a new improvement around security, and B around the OS improvement. So agenda for today, uh, around security. Previously we managed to cover the first three modules, part 1, 2 and 3, intro, platform vision and management, and for today we will be covering security. With regards security, we have 4 or 5 areas to be focused on. It's in around the new focus and OS protection plus credential protection, and then the virtual machine, and the last part is around being proactive, detect and respond to breaches. So the new focus from Microsoft was all around security, siloing and isolating issues, being able to protect, detect, respond to any breaches on customization or compromisation, rather than basically firefighting and waiting for issues to happen or occur. So these are the basically new focus, and it is a sort of like most of the security teams will advise the IT teams to basically work together in order to protect, detect, and respond on time. So the first part is around the OS. Let's have a look on 2016. What are the new improvement around protection for the operating system? We have 4 areas to cover. It's called control flow guard, configure, code integrity, and defender and virtualized based security. The first part is around the vulnerability and how we can block them. Second part is around code integrity, whitelisting, blacklisting, what I call it, script and application, and then defender, new improvement, management, what you need to do to coexist or other scenario. And then the last part is around virtualized based security. For this part will be around the OS, and then the next part will be VPS around a user. First thing is around control flow guard. So with control flow guard, what is it? When an app executes code, it calls code located in other memory address. The relationship between the code location are all well known, but not enforced. Attacks change the flow to meet their needs. What we can do here, applications are compiled utilizing CFG, which will verify the code location and it's called trusted for execution. Also, it can terminate if the location isn't trusted. Browser are the key entry point for attack, thus like Microsoft Edge, Internet Explorer and other Windows features take full advantage of CFG. Second part is called code integrity. So what is configurable code integrity? No specialized hardware required. Build gold image and run PowerShell CMD let to create the policy. Build golden image and run PowerShell to build a policy. CI policies utilized to maintain whitelisting and software which allow to be run in our environment. We can create a catalog to trusted application to simplify the admin task. No specialized hardware needed for hypervisor code integrity, which will only permit HVCI compliant. So code integrity is really useful. We will notice later on at another or later videos what benefit we can utilize code integrity about whitelisting, blacklisting, and creating policies for our application. And this will basically help around, protection or protecting our environment from untrusted applications or tools, or to minimize the vulnerability around, attacks. Now, what about Defender? With Defender, it's enabled out of the box. It's part of the Windows features and controlled via Windows Update. It will optimize run Windows Server supporting various server roles, as is integrate with PowerShell for malware scanning. If you ever decide not to utilize Defender, then you need to uninstall it, which is a bit different from the earlier release where we had to disable through the reg settings or group policy. But on 2016 If you are not using it, you need to remove it. That basically will help you around, not overlapping the same uh, process with different antivirus, which will impact the resource on the machine. Now, option number 4 is around virtualized base security. As you can see, it's a group policy wise. I can enable by group policy for secure boot and enable it for UEFI blocks, and I can enable it for integration with TPM. It is all around security for protection or protecting the credential guard with LSA, or securing the hypervisors, kernel and OS, and the firmware and attacks around DMA. It's really great. We'll see how that works and what we need to enable to secure our hypervisors, and either with Hyper-V or without Hyper-V. Let's have a look at the base security requirement. Base security requirement, I need a virtualized technology, either Intel or AMD. I need the SLAT to be enabled, and it is most of the technologies they support SLAT, otherwise they won't be able to host VM infrastructure or VM infrastructure. In order to use a secure boot, I will need a UEFI, and for attacks around DMA based, I need IO NMU as well, plus the HVCI compliance drivers. We will show you later on what you need to run in order to make sure your hardware they do meet these requirements. And a quick note around this is only available for generation 2 Hyper-V templates or VMs, which is basically the non-legacy templates. Otherwise, generation 1, they won't be able to benefit from this new improvement. Now with VMware, they do not have that currently, and Microsoft are using this as a selling point for their Hyper-V. Next, if we decide to use it with Hyper-V, then as you can see, no much requirement like the previous one, because I'm not worried about the TPMs or security or secure boot. All what I need is a secure Hyper-V second or slot available, second level address, and it's what they call Intel or AMD's processor. Also, a virtual machine must be all supporting nested virtualization, like enable Hyper-V role within the VM, and it does support Server 2016 and Windows 10. Also supporting for the lab currently with the VMware, which means you need to contact VMware to check if it's available for VMware. Next is around integration with TPMs or without TPMs, or we mentioned earlier if we need to use UEFI or Universal Extensible Firmware Interface for secure boot, then I will need it for to secure boot and credential guard, and IOMMU is required for secure boot with DME protection. And last and not the least is the hypervisor code integrity compatible driver, which is required for virtualized base protection of code integrity. Next, if I need to put more security around my environment or hypervisor, then I have TPM. TPM 1.2 or V2 are required for credential guard, which is configured to bind CG secret into a TPM instead of secure like a UEFI. If you decided to use it, then you can save the right certificate or requirement on the TPM. With TPM V2, it is required for measuring the boot or host guardian surface with TPM attestation. This is purely Hyper-V sort of like improvement and does not apply to VMware. These TPM algorithms are getting more like advanced nowadays. They do even thermal, so no more images or like lag or host, and most of the vendors are investing a lot into improving the behavior. And management wise of TPMs, you have few options. Either you can do it via ID, which means certificate everything will be managed via ID, similar to what you do with BitLocker, or you can do it via like sort of like an MBAM, or the third option, which is the most favorable option, will be through the HSM or hardware security module. This is mostly around companies with the right security team. They do shift responsibility from the infrastructure team around certificate security keys for servers, web services. And with this one, virtual machines must be Hyper-V Generation 2 to support secure boot and encryption. Other sort of like enhancement, we will see part of the readiness tool, secure MOR, supported for Windows 2016 and Windows 10 to prevent, advanced memory attack to the existing BIOS and mitigate issues. Memory overwriting request control to improve the defense against these issues, plus hardware security testability spec supporting for Windows 2016 and Windows 10, which will help around boot integrity, platform secure boot from power on, provide protection against physical present attacks and defense in depth against malware. Also, we have the Uefi Annex protection 2016, which is future enhancement. This is around attacks and against potential vulnerability in Uefi runtime and function such as update capsule, set variables, and so on. They can't compromise VPS. And the last will be around SMM mitigation. Again, this is a new feature or enhanced feature against potential vulnerability in Uefi runtime functions such as update capsule, set variable, and so on. Last part is how, with all these nice benefit we mentioned so far, how can I test my hypervisor to be sure it does meet all these requirements? Rather than me approaching the vendor, I can run very basic readiness tool. It's a PowerShell based and against my hypervisors to make sure if I'm planning to use device guard, credential guard, virtualized base security, code integrity, control flow guard, then I can see the output if they meet the requirements or not, and take the right action against it. We can see on that very basic PowerShell on the right hand side the output, and you can see the check and device guard can be enabled on this machine all the way down the yellow text, which means it's passed all the requirement, and you can see in the green virtualized based virtualization firmware check pass, so it's not very old, it's up to date. Also PC supporting driver guard or device guard. Also you can see all the way up secure boot is present, and so on. So takeaway is very basic tool, PowerShell script. You can take it and run it against your environment. Also to give you MS Info 32, which can provide summary of this output. As you can see, device guide virtualization and the requirement associated with it. Now, this is basically what I had for you today for part 4, and again, part 4, and it's the first series or A, and then we'll continue on part 4B, just to make sure we capture the relevant information around the user. A quick recap what we have just covered today during this session. It's a new improvement around the Microsoft Windows Server 2016 in relation to security. We covered control flow guard, and this feature support around vulnerability, code, interaction between the chips and the external maybe vendor as well. We mentioned something around code integrity, and we mentioned like there's no special hardware requirement, but it does require the firmware to be up to speed, updated, so we can use it to create a catalog for our apps internally, to whitelist them and prevent around unauthorized app or scripts to run in our environment. And we can create it via policies or PowerShell or the gold image. Then we spoke about Defender, the new improvement around Defender and interaction, and if you would like to use Defender maybe as an enterprise tool, and how we can benefit from ATA or ATP with endpoint protection. Then the last part, which was around virtualized base security and what you need to do around the device guard to make sure your environment or your hypervisor they can run device guard. And you can see the script on the slide, the output, to make sure you're ready to run it. Later on we will be using the same script to check for the credential guard and other benefits. At the end you can use this tool to make sure whatever security Microsoft introduced, it's useful and compatible with the environment before we move to the next action. That's all what I had for you for today. Hopefully you enjoyed the lesson, and I shall see you at the next part. Thank you very much for watching. Goodbye.